I know. It's that in-between time.
We live?
Yeah, live.
Oh.
You can also now add free guests to our broadcast.
Can do what?
Ooh, you can add your own guests.
Oh, we could do like a multi-cam. No, yeah, you could have like a camera on a tripod here and another phone over here.
Ooh.
Cut between the different. That'd be a lot of production.
That's a lot.
That is a lot. I just don't feel like talking today.
That's fine, Mac.
Grouchily wait.
Stare.
I feel like it's a me thing. He like talks to everybody, but then he's grouchy when he's with me. No, I'm just kidding.
Uncomfortable eye
It's
contact.
8 a.m. It's not fair.
Uncomfortable eye contact.
Stand in the camera.
I could quick text my friends and tell them to watch.
Harass Sam. Wake up.
Oh, he's probably dead asleep.
I'm sure he is.
Now you let us know when you're ready.
One viewer should go.
You're the director here. You want to go? All right. Welcome, everybody, every one person, to another Butterfly House Aquarium Facebook Live, where we take you behind the scenes to show you some stuff that you might not otherwise see on a visit here. Today, I'm with Michelle. Hello, Michelle.
Hello, Mac.
Thank you for joining me.
You're welcome.
Michelle is a longtime viewer of our Facebook Lives. This is her first time being a guest, though, so we're very excited to have her. Michelle, why don't you introduce yourself to the fine folks out there? What do you do here?
My name is Michelle, and I am the Director of Animal Husbandry. What that means is that I am in charge of all of the animal care when it comes to fish, as well as butterflies and our ambassador animals.
Okay, all right, that's a big job.
Yes.
What's your favorite part of your job?
I think the favorite part of my job is actually watching my staff grow and do things that they've probably never thought they would do before. This is a job that has a lot of twists and turns in it and a lot of things that you don't expect. So really getting to kind of watch them learn and create new ideas that have never been used before is a lot of fun.
That sounds like a lot of fun. Maybe too much pressure for me, but still sounds like a lot of fun. And one more question. If you could care for any animal in the entire world, what animal would you want to care for?
A leatherback sea turtle, which will never happen in my known career. Maybe somebody somewhere will magically figure out a leatherback sea turtle in human care, but probably not.
Could be you. Dream big.
Well, if we can make enough moons to feed a 2,000-pound animal, sure.
We're on the right track.
We are.
On the way. Well, awesome. So what are we going to be showing the fine folks out there today?
So today we're going to talk about water chemistry and water quality and why that is important when it comes to managing fish tanks, especially closed ecosystems that don't have any incoming fresh water from a water source.
Got it. And just so everyone knows, the reason you see a person behind us, Emily here, is because she is currently doing water chemistry.
Yep.
So we won't be really talking with her much today, but she is doing it in the background in case you're interested in watching. Maybe we'll get a few close-ups and see exactly what she's doing. So what is water chemistry?
So water chemistry is the chemical makeup of the environment that the fish live in. So it involves different types of ions, different types of bacteria, different types of chemicals when you add chemical additions, whether to condition your water or to treat an issue. And so it's going to involve changes in things like pH, whether you're alkaline or acidic. It's going to involve changes in alkalinity, which actually affects pH. Your ammonia cycle. Most people who've had a fish tank or have started a fish tank know that that involves ammonia, nitrites, and nitrates. And then sometimes we'll also look at other things, especially with our coral systems, like calcium, since corals need calcium to survive and to grow, and magnesium as well, because they'll use that to grow.
Got it. So when we say we're doing water chemistry, what is actually happening?
So what we're doing is we take a small sample of water. Traditionally, we try to take a sample of water not from the surface, because anything that's on the surface of your water probably will have a different or more contaminated reading simply because it's at the surface. So we try to take a water sample from further in the water column, part of the way down. And then what we do is we'll actually take that water out of the container that we put it in, and we'll start putting it into little tubes or little glass vials. And then we add certain types of chemicals to create reactions in that water, and those color changes from those reactions tells us what our pH is, what our alkalinity is, whether we have enough calcium or magnesium.
Got it. It's very interesting. How often do we do these? Do we do them, every single day? Do we only do them once a week, once a month?
So we do most of our water testing once a week. All of the staff here kind of has their own tanks that they test so that everybody gets a chance to do it, because it's really important for them to understand how that works. There are some tests that we only do once a month. So those will be things like nitrates, because nitrates are the less toxic part of the ammonia cycle. And things like phosphates we'll only test about once a month as well. And phosphates are basically things inside your tank that can create algae growth. And can also cause your tank system to not be very healthy for things like corals who struggle with high phosphate levels.
Got it. And why don't we do it every day? I know you said for like the nitrates, those are the less toxic ones. So what about for some of the other?
The reason we don't do it every day is typically we'll do water changes once a week on our systems. Our water changes are not big, so we're not taking a lot of water out because that will completely mess up the chemistry. We want it to be stable. So we'll do anywhere from like 10 to 35% water change depending on the size of the system, or if we have issues with it, if we have high ammonia. Testing every day isn't going to give us any different readings. It's probably going to be very, not necessarily perfectly linear, but it'll have a very similar show for each day that we were to test it, because water chemistry in a tank doesn't change over a week. It tends to change over a month's time is when we start seeing drastic changes.
Interesting. So I know you mentioned some of the things that we test here, but how many things do we test here overall, even on a monthly basis?
Overall, we're probably testing about anywhere from 8 to 10 different types of things. It depends on the system. It also depends on if we have a problem. So if we have a system that's not acting right, we've got corals that are starting to melt, we've got animals that are acting weird, we might pull out some other tests that we don't traditionally use, just to make sure that we don't have something going on that we can't see.
Got it. So, and you kind of already sort of mentioned this, but we'll ask it more explicitly. Why is water chemistry important? And also, what can happen if you're not paying attention to your water chemistry, if you're not being careful with it?
So water chemistry is important because you've got things like fish, corals, and inverts living in a tank, and that tank is where they eat, where they sleep, how they breathe, where they defecate. And so these animals we're putting a lot of stuff in there by feeding them. They're putting things in there by defecating. But because these animals live in an enclosed environment that we don't have a constant flow of water moving through like the ocean would be working, we have to make sure that we're managing their environment appropriately so that we don't make them sick. So different things can cause fish to have something like clubbed gills. And so when a fish has clubbed gills, they can't breathe properly. Fish can get bacterial or parasitic infections because something in their water chemistry is off. And then you have to add chemicals and medication to their tank to treat them. And for animals that are really sick, that could be a death sentence. For animals who have an immunity to types of medications, you might be going through 6 different medications before you actually find a solution. And water chemistry it dictates how healthy your environment is. And this actually also applies to the ocean itself. How healthy the ocean is dictated by what the water chemistry in the ocean looks like.
Well, and I'm glad you mentioned the ocean, because I've always wondered, obviously the exhibits we have here, the tanks we have here are fairly small, especially a lot smaller than the ocean. How does water chemistry in the ocean work? I know it's a really broad question, but is it, kind of the same overall? Is it pretty homogeneous, or is it really just dependent on where in the ocean you're testing? So
water chemistry in the ocean can actually be the same and also dependent upon where you're testing. Mm-hmm. So the ocean, because it's much bigger and it's an open space and it's not maintained or controlled necessarily, it's a little bit harder. You can't really pinpoint or specify or put it in one particular place. So things that affect ocean are things like chemical spills, pollution, plastic trash, whether the water is too hot, whether the coral reefs are dying, whether certain species of fish and inverts are dying. And so in different parts of the world, there are different qualities to the ocean. There are dead zones actually in the ocean where things can't live, or if anything lives in there, it's maybe like 2 or 3 different animals that have somehow figured out how to adapt to an environment that is just not healthy for other living things to live in.
Interesting. For our tanks here, are they all relatively the same in terms of their chemistry levels, or does it differ a lot between the tanks?
Yes and no. So we have some cold water systems and we have warm water systems. Our warm water systems tend to be fairly similar as far as how their water chemistry changes or adapts. It also is based on how many animals are in the display. So if we have a display with 1 animal in it, obviously the water chemistry is going to be very different than a display that has a large community of fish and corals in it. We also have cold water tanks. And what's interesting about cold water tanks is that their water chemistry actually changes less frequently, and it takes longer to make an adjustment to something negative because the water is cold. And so the bacteria that grows in there, it takes them a lot longer to grow. And you can actually see that in things like our jellyfish. We keep our moon jellies at 60 degrees. And that's because if we keep them higher than that, they'll grow very, very large, very, very quickly, and then we won't have space for them.
Huh. It's interesting. I never thought about that, but it makes sense. What types of things can cause water chemistry to change quickly? You know, something almost like, what could make a tank have really like catastrophically bad levels really quick?
So one of the things that can do that, and people in Sioux Falls will appreciate this, is power outages. So if you lose all of your filtration, everything that runs your system, that filtration is usually where your bacteria lives. Some does also live in the substrate in your tank, but when there's no moving or running water in a tank, what happens is that you've got nothing pulling out the bad things like the nitrites, the ammonia, the poop, the leftover food, and so that's just building up in the bottom of the tank with nowhere to go. Another thing that can change it is deaths of animals. So sometimes animals will die and we can't find them. Whether they went under a rock and died, whether something tried to eat them and pulled them into a place and they died. So when we see strange water chemistry, we're going to start looking for stuff like that. Another thing that people probably don't think about is metal. So if we were to accidentally drop something metal in the tank that would rust, over time that rust would leach metals into the tank that could negatively impact not only the water chemistry but also the animals that live in the tank as well. And if we add chemicals to a tank or medications and chemicals can actually change the makeup of your tank. We have stuff that helps us raise the pH or lower the pH, change the alkalinity, and sometimes when we put those things in there, it can actually change other things in the tank as well, simply because it's trying to balance itself back out. The environment that we keep these animals in has to be a very balanced ecosystem.
That makes sense. How sensitive are the animals to these changes?
Some animals more than others. So animals like jellyfish, for example, there's a lot of times that we've seen their ammonia and their nitrates like exponentially high, whether it was because we just redid the whole system and we, tried to get it started back up, but we put too many animals in it one time. Those animals seem to be able to adjust to changes fairly well. Now, that's in the short term. Long term, if we kept them in those environments, then you might see things like bell shrinking, lack of eating, flipping inside out, deterioration of the bell. So it is important for us to change those things, even if the animals can handle it for a few days. Animals like seahorses can be pretty sturdy unless it is like a smaller species of seahorse. They might struggle if you've got high nitrates or high ammonia in your tank. Invertebrates are very sensitive to change in tanks, so things like corals. Corals are probably one of the hardest animals to take care of. And so if your water chemistry changes in your coral tank and you're not paying attention to it, your corals will let you know that something's wrong because they start to do things like release the symbiotic algae that's inside of them, which makes them turn white, or they'll start dying or melting or sloughing off their skeleton.
Got it. So generally, short term, it's not always horrible, but over long term, it's going to almost always be pretty bad for the
Correct.
animals. Got it. What can we do when the chemistry goes wrong in the tank, or we need to fix something? What's that process? So
one of the easiest things for us to do is a water change, and it's usually the most recommended thing to do when you have chemistry issues in a fish tank. So adding a whole bunch of chemicals to a tank, it's not an ideal way to manage a problem, and it doesn't necessarily fix the problem at the root. It just temporarily fixes it. A water change fixes it at the root, because what you're doing is you're removing all that water that's not healthy for those animals. You might be siphoning your substrate to just pull stuff out of it that's, you know, poop, waste, leftover food. And then when you're putting water back in, it all mixes back together to help drop those levels. A lot of times if you have really high ammonia or nitrites or nitrates, you'll do small water changes throughout the week. So instead of doing your large 30% water change, you'll do a 5 and then a 10 and then another 5 and then maybe a 10, just to try and like not shock the system. Because if you do a really large water change, and sometimes you do those are emergency situations. Sometimes you might do what we call a dump and fill, where you literally just dump everything out of your tank and fill it with brand new fresh water. And that's if you got a crisis situation going on and you know you're going to lose everything. But most of the time you try not to go down past 50%, because once you get into that, that's that zone where you're pulling out all of the healthy bacteria with the bad stuff, and then you have to rebuild your bacteria colony.
Got it. That sounds tough.
It
That
is.
sounds like
It
something you don't
is.
wanna do, for sure. Okay, my final question. We talked a little bit earlier about water chemistry for the ocean, and how that can change and what can cause that to change. How do fish adapt to that? Are they able to adapt to that? Can fish, are they... Do those changes in chemistry in the wild negatively affect fish, and how so?
So that's a yes and a no. It depends on the animal. It depends on the environment that the animal is used to living in. So the ocean is a little more complicated as far as this is concerned, and that's why it's kind of important for people to pay a little more attention to it. Things like jellyfish, for example, are being seen more frequently now. And that's because the ocean is becoming more acidic. And jellyfish can handle an acidic environment. A fish, on the other hand, probably can't. They might get burning in their gills. They might end up developing infections because they're not used to super acidic water. The overabundance of jellyfish is not a great thing. Yes, it's a food source for some animals, but that means if they're overabundant, the animal that's supposed to manage their population no longer lives in that location. And that's just because they can't live in it. Temperature rise in the ocean is probably one of the biggest things we're dealing with right now. As far as coral reefs are concerned, it's kind of astounding to see what corals have started trying to adapt to in order to survive. There's been a lot of die-off on like Great Barrier Reefs, the one in Australia, the Great Barrier Reef that's in Florida. A lot of those are dying very rapidly just because of chemical changes in the water, temperature changes in the water. But they're starting to see things like corals creating their own sunscreen because they need to survive. And the whole point for all of these animals is they want to live. So they're going to try to adapt as much as they can, but there is a point where animals can't adapt anymore. And so when we're putting pollutants in the water, when we're putting a whole bunch of trash in the water, I don't think people realize how much trash actually can change the temperature and the chemistry of the water, because there are a lot of chemical processes in making things like plastic or metal or rubber or things like that. And so those chemical processes will leach out, and it doesn't just stay in the one spot, because the ocean is a continuous moving body. So it moves around all over the place. So if something's really bad down in the Gulf, say you have an oil spill, that's not just going to stay in the Gulf. A lot of times if you can't clean it up in enough time or you can't handle it, it's going to start traveling to other parts of the world. And so animals will adapt as much as they can, and then after that point, that's when you're going to start losing them.
Got it. Well, that's all the questions I have. Thank you very much
Of course.
for taking time to talk to us. Is there anything else, water chemistry related or otherwise, that you would like to tell people about?
I think that it's really interesting for people to want to show interest in things like water chemistry, because people don't think about that. We see a body of water, especially something like an ocean, and we're like, oh, it's a big body of water. It just kind of exists. And I think it's better for people to pay more attention to, well, where are the dead zones and why are they dead zones? Like, start asking those kinds of questions. What happened in that space? Is the temperature too high? Is the pH too low? The other interesting thing about water chemistry too is that you do get a fun little rainbow of like colors. So all of these chemical processes create all kinds of different colors. Certain ones will, so our alkalinity, it tends to turn like green or blue. Our calcium will turn orange. Our nitrites and our nitrates will turn pink. And being able to do that, I think the reason that companies created the ability to do that is because people are visual. And so it's easier for us to say, oh, that looks way brighter than it did last time. That must be a problem, versus what it should be, you know, in other situations. Now, this is a very simple water chemistry testing situation. In larger facilities, you're going to see things like large machines. So probes that they just put into the water, and the probe reads everything as the water circulates around the probe. And so those kinds of testing processes aren't as labor intensive as this. This is pretty labor intensive to have to do all of these, fill all of these tubes, and then she puts it in something called a colorimeter, which just reads the color and tells her what that value is based on the color of the water itself.
Interesting. And I didn't know that at larger facilities they could just go, "Boop."
Yeah, it's great.
That sounds cool.
It's great, and they have lots of equipment to like turn samples, to spin samples around. So, you know, they'll set a timer and then tell it what it wants it to do, and then it'll just do it for them, and they can read the samples after the fact.
I bet Emily would agree that we should get some of that.
nice.
Yes, it would be very nice.
All right, well, if that's all you
That's all.
have, again, I want to thank you very much for taking time to talk to us about water chemistry. I know some people might think it's boring. I think it's interesting. It's really interesting to me. You know, if you go to the beach or if you go walk by the Big Sioux River out here, kind of think about what is going on in that water. You know, it's real easy just to look and say, "Oh, it's water, water, it's water," but water is not water. It's
Correct.
lots of different types of water.
Yep.
Which is just really cool.
It
And of
is.
course, as always, I want to thank you, dear viewers, for joining us today. We always appreciate anyone who takes time out of the day to watch. And hopefully you'll join us next time when we go behind the scenes to see something else here. Until next time, bye-bye.
Bye.